Live from the Washington, D.C. area, it's the Inside Scoop, EmeraldPlanet. All the ecology news that our viewers want to know. Now, here's your host, Executive Director of the EmeraldPlanet, Dr. Sam Lee Hancock.
Hello and welcome to the EmeraldPlanet as we come to you from around the globe in the United States, Washington, D.C., looking at 143 different nations, looking for those best practices, the technologies, the services, the products, and the people are making a difference in the 21st century. We're trying to describe and to relate to you, the viewer, what is actually going on in the world, which are really the best practices. And so many of the topics, the ideas, and the images that you're seeing are what's actually being implemented and applied sometimes within your own local community. Other times it may be a unique technology or product that is actually could be implemented at where you are living. And so we bring experts on each week to talk about what it is that we're doing. And one of the programs we've been trying to have on a very long time is about the Blue Plains product and projects in Washington, D.C. This is the largest tertiary wastewater treatment facility in the entire globe. Many people say, ho hum, what's the big deal about that? Well, when you have almost half of the world's citizens, 3.5 billion people, who do not have access to wastewater treatment to take all of the pollutants out of the water before it goes into the tributaries, it's a very big deal. And we're going to be seeing this humongous plant here. Dr. Sudhir Murthy, who is the manager for the research and laboratory, it was called DC Water. It's both for water and wastewater, is sitting with me. And Sudhir, thank you for being here.
Thank you. Thank you for having me.
This is absolutely, I want to bring the slide back up. This is absolutely a massive project. When you talk about 153 acres in one facility trying to just deal with wastewater, this is a big deal.
Yeah, that's correct. And it's very few people realize what a challenge it is to treat wastewater. It's this flow that comes into the plant.
Well, actually, we just discharge it as human beings.
Exactly.
It goes away. We don't have to see it in as far as Western society and many places in Asia and sometimes in South America. But when you have almost 85% of half of the world's population, but 85% of the landmass where you just don't have this, I mean, people have to deal with it on a one-to-one basis. Where here we just discharge it and it's gone.
Yeah. And in that large part of the world, it really impacts public health. And really, I think in the Western world, we take that for granted because we live healthy lives. But not treating wastewater is one of the largest causes of public health impacts in the world. Right
well, now. 50% of the infants actually, or children under 5, die from just dirty water being around them or ingesting dirty water. So this is really just something that's, and this plant is so massive. And tell us a little bit about the background of this, just the plant itself, and then we'll talk about the territory, because the territory is, again, huge. As far as square miles are concerned, and so share about that.
Yeah, so the plant was actually conceptualized in the 1890s. So in the 1890s, there was a board that was formed to actually discuss the building of this plant, and by the time they actually built the plant, it was 1938. So they had another board that looked at the plant. They decided, to keep the combined sewer section combined, and then they actually built a separate sewer section in Washington, D.C., and then all of those flows was channeled towards the Blue Plains plant, which is really in the southern tip of Washington, D.C.
And we have a layout here as far as the different areas, and understanding this is almost 800 square miles of territory that this really covers. And so it's just a massive area when you're trying to deal with, wastewater. And then, of course, the wastewater, Sudhir, as we know, includes what's actually happening now is to separate out all the stormwater that's going into the drains, too, which is an additional cost.
So the blue section, as you see in that chart, is the combined sewer section of our entire sewer shed. And then we have the we have the separate sewers in the remaining sections, and we actually serve parts of Fairfax County, we serve parts of Loudoun County, and the southern parts of Montgomery and Prince George's County, as well as the entire.
Yeah, and I was going to say, this is some of the largest counties in both Virginia and Maryland, so these are a huge population base, and of course it's not as big as maybe some of the mega cities that we'd have overseas, but as far as the area that you're serving, it really is a huge area, and this gives us another idea, Sudhir, of just how expansive this entire area is.
Yeah. So, one of the longer sewer pipes are, I think, over 50 miles long. So that gives you a sense of how long it takes for that water to get to the Blue Plains plant.
Well, also, too, I think there's like 1,800 miles or something like that of piping that goes into this whole thing. I mean, these numbers are just astronomical. Yeah. What are we looking at here?
So what you see out there is an old picture of Blue Plains. It's a picture from the 1930s. This was before the plant was built out, and you can see that the plant was very small. It was serving just 500,000 people, and all it was doing was removing solid material from wastewater.
And this is what we call primary system as far as taking it. And then it expanded to the secondary, and then, of course, now it's at the tertiary level that we're talking about now, which is the highest that you have. But one of the things, when I was out on my tour with you, you were talking about how this is one of the features of being the most advanced plant on the globe, is that you have to protect both the rivers, the Chesapeake Bay, and the Atlantic Ocean, which is a huge task and very expensive. Tell us about the separation that you're doing and why it's so complex in your factory.
So we all eat food, and food contains what we call carbohydrates, proteins, fats, and if you go back to the individual molecules in these carbohydrates, protein, it really consists of carbon, nitrogen, and phosphorus. And in the end, what we try and do is remove this carbon, nitrogen, and phosphorus from the wastewater, because if we didn't remove it, it would harm the fishes in the river, or it would cause algal growth in the rivers or in the Chesapeake Bay. And it so happens that we want to remove the nitrogen for the Chesapeake Bay, because any additional nitrogen will cause algae in the Chesapeake Bay, and we need to remove phosphorus for the river.
And we need, for many of our audience that are abroad, the Chesapeake Bay is one of the largest bodies of water as far as the brackish, the tidal area, where you have both fresh water and salt water, mixing in that area. Exactly. And so it's a very delicate environmental balance that we have between those two. So then why are we extracting the nitrogen from the water?
So in general, when waters get saline, when the waters get salty, there's usually enough phosphorus in the water. There's always enough phosphorus, and so if any additional nitrogen that goes into the water is what causes algal growth. And so because algae are like almost any other living matter, they contain the same carbon, nitrogen, and phosphorus. We contain carbon, nitrogen, and phosphorus. And if the algae already have carbon and phosphorus, any additional nitrogen causes their growth. And we want to prevent that growth. And so we want to remove that nitrogen to prevent their growth.
Now, looking at this plant, this is very complex. And I know that this is something that many of our viewers that have a technical or engineering background will certainly understand. What are we looking at here, and what are some of the complex issues that are being addressed by the technologies and the products that are going on here?
So in general, the early part of the plant, as the plant flows, so the water flows down the plant, and it takes anywhere between 8 to 10 hours for water to flow down the plant. And the early part of the plant is just for removal of carbon. And as we go down the plant, we do more and more complex treatment. And that's where we start removing nitrogen, and we start removing phosphorus. And so what's unusual about the Blue Plains plant is we do very stringent levels of removal of carbon, nitrogen, and phosphorus, really unheard of, all in this one location.
Yeah, and I understand that as far as other plants, I call them factories around the globe, really is that you're either taking out the nitrogen, you're taking out the phosphorus, and or a combination with the carbon But this is really the only plant as far as the world is concerned where you're taking out all three simultaneously.
To very low levels.
At very low levels as it's going
into
the water. And of course, you have this tributary. And many of us kind of forget, yes, it's going into Potomac, it goes into Chesapeake Bay, we need to improve those. But we don't realize the impact that we're having from this region on the entire globe, because once it gets into the Atlantic Ocean, who knows, you know, through the tides and through the water flows where all that water is actually going to end up.
That's right.
And it's everywhere out there. So looking at this treatment here, what are some of the processes that we're looking at and in a very simplified fashion?
So the slide that you see out there is really what we're trying to do coming up now. We have this, what we call this wet weather treatment plan, where we hope to bring all these combined sewer flows to the Blue Plains plant rather than it going out into the Anacostia River or in the Potomac River without being treated. And so we are designing these projects that will build tunnels underneath Washington, D.C., and then bring that flow to Blue Plains plant where it will receive what we call enhanced treatment.
Now, understand this part of this is about $2.3 billion. Now, that's with a B,
that's
$1 billion. That's a lot of money. And everything that you're doing in this whole, and I'm going to go back to this slide here, what we're talking about is really almost $4 billion worth of investment. As I understand, this plant's now worth, what, somewhere between $2 and $3 billion itself as it sits. So we're actually having about a $7 billion facility.
Infrastructure.
That's a huge investment by the public. And this is where we're going right now. Tell us where we're going in the last minute, where we're going to be in the future.
So what you see out there is all of these different projects coming together. And you know, we had to think about all of these new projects and how they actually interact with each other and come up with a concept that works. And so we have a nitrogen removal facility, we have actually a facility to recover energy, we have facilities to treat wet weather. So all of these are coming together all within the next 4 or 5 years.
Now, I understand it's about 10 million U.S. In savings as far as energy that you're not going to have to be bringing in from the utilities, so you're becoming more self-sufficient and all that. And also that the overall cost savings is about $28 million. Is that in a month or is that in a year? The total savings as far as everything.
So what we expect is...
we have only a few seconds.
We have an energy program, and we expect to have several $1 million of savings per year just from energy.
Okay, that's very good. Thank you for being with us as we look around the globe to create the Emerald Planet.
This year, 28,000 Americans will be diagnosed with oral cancer. Every year, 7,000 Americans die of oral cancer.
I'm Eva Cohen, and I'm an oral cancer survivor. I didn't fit the profile. I didn't smoke or drink. I had no family history of cancer, no family history of cancer. I was 31 years old. 31 years old. I went to see my dentist about a sore in my mouth that wouldn't heal. It was oral cancer. I had to have a radical neck dissection and a portion of my tongue reconstructed. I didn't know if I was going to live or die.
I'm Surgeon General Richard Carmona. The survival rate for oral cancer is only 50%. Oral cancer can happen to anyone. If you have a sore or lesion in your mouth that doesn't heal within 2 weeks, see your dentist. Early detection is the key.
Early detection saves lives. I know.
1 in 8 Americans goes hungry. One idea helped change that. A community started a garden that blossomed into farmers markets. 1 in 6 children lives in poverty. One group of women found an answer by opening a daycare center that their neighbors could afford. Today, 36 million Americans live in poverty. But one by one, people are helping themselves and each other to change the picture of poverty to one of hope. For easy ways you can help, visit povertyusa.org.
2 words for you. Pop quiz. Ready? Name any funny movie. A drama. Name a mystery. And one more thing. Name the movie your kids saw today in science class.
Know what really matters. Know about your kid's school. and know about your kid. Find out 100 ways to know more, do more.
To the Emerald Planet as we come to you from Washington, D.C. in the United States, looking around the globe for those hundreds and thousands of best practices that can be used to bring about a better life on this planet as we go from 7 billion to possibly 9 billion souls by 2050. So what are we looking for? What are we doing as far as dealing with these many issues? And one of the most urgent issues facing the globe right now, of course, is the shortage of water, potable water for people who need to use that for sustaining life. But also wastewater actually is becoming a much greater impact, negative impact on the lives of so many people, with almost half of the world's population having no access to wastewater treatment. We have a specialist with us who is called a Biosolids manager. This is a Biosolids fertilizer. And Chris Peot, and we were chuckling about our viewers in Paris will say that Americans can't really pronounce any French names, but well, that's how it is in the United States, right, Chris? And he's working with the DC Water, which we've seen the size and scale of that. And we have a slide here that's going to put up some of these numbers, and it's just absolutely amazing what we're doing. But looking at this whole thing about biosolids, what is a biosolid?
Well, biosolids are the treated residual that comes out of the treatment plant. As Sudhir mentioned earlier, we are limiting the pollutants that go out into the bay. It's really important to do that.
Now, which bay is this?
This is Chesapeake Bay, I'm sorry.
Okay, you got an international audience, so we've got to be sure to define everything.
And we all understand that that's a resource well worth preserving, and our discharge limits are have limits to the nutrients. So we're trying to prevent the nutrients from going out into the bay and causing algae blooms. Well, the nutrients don't go away in the process. Some of it gets blown off as nitrogen gas, but a lot of it gets captured in the solids. And it's my job to treat the solids to EPA standards so that it's suitable for reuse. And right now we have a program that recycles 1,200 tons a day. That's about 60 or 70 semi-loads a day of treated human manure. And it largely goes to agriculture in Virginia and Maryland. We've got agricultural sites in 39 counties in 2 states. We have a silviculture program where we fertilize forest land. We have several reclamation projects that we've done where we have soil of poor quality because of mining, bring it back up to a natural state.
So what we're doing actually, Chris, in all this, we're looking at, again, this nitrogen, phosphorus, and carbon that we're actually extracting out of all this because those are natural elements. Then we're putting out on the soil. And the whole thing is that we're not just trying to stop what's happening at this time. We're actually trying to improve the environment. So that's air, water, and land. All 3 of those we're trying to improve through this very expensive process.
It is. I actually refer to Blue Plains as a nutrient recovery facility. We're recovering water, of course, nutrients, carbon, and energy. And all of that right now is going out to the fields, the farms, and we don't extract much value from that. We're glad that the farmers are using it. They are avoiding the use of manufactured fertilizer, which takes a lot of energy to make, of course. And when we use
also we're importing the petrochemical inputs in order to be able to produce this chemical fertilizer. So being able to take all this human waste and then put this out into the farms in a sterilized format, so actually we're not putting pathogens into the soil, is a very good thing for the environment and actually for humankind in general.
It is, and our future holds even more technological advances. We are going to, we've actually broken ground on a project to build digesters with a very innovative pre-digestion process to convert half of the organic matter that's in the biosolids to methane. And then we're going to burn it in a very clean burning turbine to create power. So that's what the future holds.
Now looking at this map that we have here in front of us, you can just look over my shoulder. What are we looking at here, and how does all this relate to the biosolids and what you're doing as far as DC Water is concerned?
Sure. This is our current program. This is, I think that this is June of 2011. This is all the different counties that we went to with the material for the month of June. It's a very diverse program. A lot of the counties have slightly different regulations and ordinances. But the graphic there shows, I don't know if you can read it on
No, you
the
won't be able
screen,
to,
but
but-
it shows the tonnage that goes and the value that the farmers are extracting from it. The farmers routinely testify that it's worth about $300 an acre to them because of the value of the nutrients and the carbon that they're getting.
Okay, so taking this, the biosolids out of, we're extracting this from a huge area, bringing it in, processing it, putting it out into the land, which is going into many useful products. Also, it goes over not only for just food production and as far as meat production as well, but also into the ornamentals, which is really good as far as being a carbon sump and extraction the carbon from the air. So really, this is a very sophisticated process that we have here, where you're taking, again, the phosphorus, the nitrogen, the carbon out of the solids, but also not only you're taking it and putting it on the land to provide the nutrients, but you're actually providing an enhanced environment extracted from the air itself.
It is, and there's all this anecdotal evidence that we get from farmers. The farmers always say that the crops that they have resist drought. And we always thought it was because the organic matter was holding more water, but if you do the math, it's not holding enough water to make that big a difference. And we've done a lot of research at Virginia Tech showing that...
And that's the land-grant university for Virginia.
Thank you. Showing that the microbes that are in the biosolids that come from the treatment plant, that are actually come from our guts, ultimately, are extracting these essential plant hormones that plants need to get through stressful conditions. So it's really great for the farmers.
So what it's doing is really strengthening the root system, and this is one of the things that I think with Bill Melinda Gates Foundation, they're saying is that the greatest threat to humankind as far as food security, water, and everything else is the poor quality of the soil, and actually the quality of the soil has continued to decline as we overproduce, food materials and fiber. And so this is one way actually we're giving back in a very significant way back to the soil itself.
It really is. It's difficult to find a farm that has an optimal level of carbon in it because farming is very hard on the soil. So the farmers are always looking for more sources of carbon to put back into the soil.
Now, looking at this, you're trying to, of course, this is we'll save that for just a few minutes. Tell us what we're looking at here as far as this distribution out to the farms.
Sure. This is just showing one of the trucks, or I think it's two trucks, dumping onto the field, and it arrives in a state where it looks like wet mud. And then from there, it is very much like traditional farming. It gets put into a manure spreader and spread. We have to adhere to slightly more stringent buffer restrictions than farmers that use inorganic fertilizer. It's just an extra measure to help protect the waterways in the Chesapeake Bay.
And make sure, again, we don't have the nitrogen, the carbon, the phosphorus running off into the soils. Now, looking at this is something from satellite. What is this image?
This is a project that we did, a restoration project. This is the Stafford County Airport. It's a brand new airport that was built, 12 years ago. Relatively new. And of course, if you want an airport, you want it to be flat so you can land airplanes. And they cut into some hills and they spread out the sediment, and they couldn't get any grass to grow. And it turns out that they cut into a naturally occurring but extremely acidic vein of pyrite, which is very sulfurous, and they spread it out all over the whole site. No fault of theirs, really. And they had pHs as low as 2, 2.5. And we said, hey, we've got lime-stabilized biosolids at pH of 12. We can come in and restore this. And now they have thigh-high grass, and they're worried about mowing and things like that. It was a really nice solution.
So they go from one extreme to the other.
Yes.
But talk about this lime being added. I know this is part of the process as far as processing these biosolids that's actually coming out of the Blue Plains plant. Tell us why you're adding the lime and why the farmers like that so much.
Sure. It's a lot of times farmers will add lime just to adjust the pH of their soils. And we add it as a way to limit the pathogens. It's one of the EPA-approved methods to limit the pathogens. We raise the pH to a level that the pathogens don't like, and it's okay to bring it out into the field at that pH because the farmers like to adjust the soil pH anyway.
Looking at this slide here, this is something as far as a restoration project. What's going on here?
Sure. We are producing a compost product also with our biosolids. We have such a huge program that we can slice a little bit off and do some innovative things. We have 50 tons a day going to a compost facility in Virginia. And we're bringing a lot of it back up into the city for tree planting, low-impact design, runoff limitations, things like that.
Now, looking at this is getting really to the essence of the processing and also how you're actually trying to have a very positive impact on the environment. We see the lime here, and we see all the filtration that's going on. How would you describe this to our viewers so that in a very simple way we're talking about how we're reducing the carbon footprint to the earth at the same time providing real value to the farmers and to the citizens?
Sure. That is the schematic of the new energy system that we just broke ground on. The line on the bottom is what we're currently doing, and the line in the middle and up above is what we're doing in the future. The digestion process, it's an anaerobic process. Anaerobic microbes respire methane. We're aerobic entities. We respire CO2. So they produce methane. We collect it and burn it in a clean-burning turbine and recover heat off of it to go back into the system. We have a very innovative pre-processing system that allows us to, it's called thermal hydrolysis. It allows us to digest the biosolids in about half the tanks that we would normally. And out of the tanks, we get methane and a very high-quality Class A biosolids that we'll be able to make a soil product with and recycle in the city as well.
So we're enhancing what we're doing, but also understand it's about $10 million worth of offsets that you'll be able to produce out of this plant?
Yes. The energy production is about 13 megawatts of power. It takes about 3 to run the system, so it's a net positive of 10 that we will get out of it. And that 10 megawatts is worth about $11 million a year. There are other savings associated with the project.
And that runs about 8,000 homes, I understand.
Yep. 13 megawatts is enough to run about 8,000 homes. We're going to use it all on site because we are a large user of electricity, the biggest user of power in the district. And because of that, we also have the largest carbon footprint. And this project alone is going to cut our carbon footprint by a third, by 50,000 metric tons of CO2.
That's just absolutely incredible. And this is really what we're getting to. This is the essence of everything. We have about 30 seconds left. Chris, what would you like to share with our domestic and international audience, that their takeaway from everything they've seen about both extraction, putting it out into the agricultural community, but also producing their own fuel?
Well, sure. I live this every day, and I enjoy tremendously what I do, but I want people to understand that this is a resource that all cities should be using and taking advantage of. You cut your carbon footprint. You can make a product to use to grow trees, reduce the temperature of the city, reduce runoff.
Just so many benefits, and thank you for being with us as we create the Emerald Planet.
Just books at the library.
There's more than just books at the library.
Excuse me.
There's more than just books at the library.
Il n'y a plus que de livres à la bibliothèque.
Hello. You have a lot of great books here today. You know there's more than just books at the library.
I know.
There's more than just books at the library.
I don't want to be hooked to a machine.
I want all the medical treatment available to me.
I wouldn't want my family to have to make this decision.
My doctor knows what's best for me.
An advance directive is your life on your terms. Talk with your family. Decide what's right for you. Then put it in writing.
Documenting my wishes today means my family won't have to make heart-wrenching decisions later.
To learn more, visit www.putitinwriting.org.
1,200 American youth run away from their homes every day. The National Runaway Switchboard is here to help. 1-800-RUNAWAY. If you are a runaway, thinking about running away from home, or a parent or guardian concerned about issues facing your child, call us 24 hours a day. 1-800-RUNAWAY. In times of crisis, hope is just a phone call away. 1-800-RUNAWAY.
We're back to the Inside Scoop Emerald Planet. Here again, your host, Dr. Sam.
Welcome back to the Emerald Planet as we come to you from Washington, D.C. in the United States to talk about the technologies, the processes, the services, and the people that are making a difference around the globe. Looking at the whole notion of wastewater treatment. This is one of the things that many of us, if we're living in modern industrial states, just don't really think about. We use the water, it goes down the drain, it just leaves our homes, our farms, commercial buildings, and it's just gone. And we turn on the tap, and there's just more clean, pure water waiting for us. But in most of the world, that is really not the case. Over half of the world's population, some 3.5 billion people, face a real challenge as far as gaining access to clean water and also to take all of the pollutants, the air, the water, and the soil, out of the various wastes that are being discharged in a very unhealthy manner. And it affects the education, the health care, every aspect of our lives because of loss of productivity among the workers and the citizens. And so we have an expert sitting with us here, Donal Barron, who is the head of the Clean Rivers Project. He's an engineer as well. We're having Engineers Fest with this television program we're talking about. And of course, we're talking about the Blue Plains project as going on in Washington, D.C. It's the largest tertiary water treatment facility in the entire world. And they're investing another $4 billion U.S. in this whole facility to raise it to another level so that we can have a positive impact on not only the Potomac and the Chesapeake Bay, but also the Atlantic Ocean that impacts on many citizens all over the globe. And so, Donal, thank you for being with us.
You're very welcome.
And tell us a little bit about this Clean Rivers Project. We're going to have some slides here, and we're looking at some of this in front of us. What are we talking about, clean rivers, and how does that really impact our day-to-day life and the day-to-day lives of people all over the globe that are around the Atlantic Ocean?
Well, not the head of the Clean Rivers Project, but we have been working on it for some time. And the problem, the issue really is the combined sewer overflows. You know, most people are familiar with a separate system where you have one set of pipes that takes the wastewater and effluent away from your home, another set that takes care of stormwater, the massive amounts that come down and fall on the streets.
Of course, in many of the older cities, before we worried about much of the runoff going into the rivers, is just, you know, if you had a pipe, there was going to be water, you just put it all in there, and then, in essence, it would just go out into the river, in many cases, untreated. So looking at this, separating this out, what is a combined sewer system, and then what is a separate sewer system?
Well, if you look at D.C., basically one-third of D.C. is combined sewer system, and the rest is separate. So what the difference really is that for the combined sewer system, you only have one set of pipes. And they're supposed to take this sanitary waste plus the stormwater. And they work fine when it's dry or when there's just a little rainfall. But when a tremendous amount of rainfall falls, you know, or a large storm, the pipes are just too small. And what happens, of course, is that you know, the system was designed that you know, when it was built in 1900, 1910, that it would overflow. Otherwise, what would happen is it would back up into people's homes and on the street. So it was designed that way, and it was state-of-the-art engineering at the time.
But we're moving on into the 21st century. We realize that we can no longer just keep discharging all this waste or having all this stormwater. And also, at the same time, we really don't want the ratepayers, the taxpayers, to have to be treating just stormwater that's going to go in and it's just be actually just flushed right out into the rivers. And so how are we bringing about now this delicate balance, and how does this relate to, again, this Clean Rivers Project?
Well, all the cities that have systems like that are mandated to come up with a plan to drastically reduce combined sewer overflows. So we started back in 1998 We did planning, did a long-term control plan to come up with a plan. You know, there's various technologies. There's one is storage. You know, you can store the combined sewer overflow and then release it as the rain abates and get it treated. You can separate it, or you can do low-impact development. There's several different things. You'll find that the larger cities like D.C. or New York or Philadelphia, that a large part of their solution will generally be storage. And storage in this case means deep underground storage. In our case, it means 13 miles of 23-foot diameter tunnel.
And I'm going to say that's very expensive, and we're looking at this map here. Just kind of walk us through this, Donal, what we're looking at here, the difference between the yellow and the red lines, and what is the economic impact on the city itself, but also the ratepayers with this type of system?
The project is projected to cost about $2.5 billion.
And that's with a B, billion dollars.
With a B, yes. And over a period of 20 years, we're about 6 years into it. What you're looking at is the plan for the Anacostia River. It's got 13 miles of 23-foot diameter tunnel, and it ends down at the Blue Plains Tunnel. There are similar tunnels planned for the Potomac and Rock Creek, but our hope is that on those that we will be able to, we have an initiative for green infrastructure.
And I think this is just really the way that the world's going in the future, because it's a way they actually take something now that we're looking at as waste, the storm water is going in with the combined waste, you know, from the homes and the farms and the commercial buildings, and actually using it as a resource and to cut down on the investment. So this looks like something very major is going on here.
This is the first piece of construction. This was preparing a site at Blue Plains to install the tunnel, or sink the shaft to begin the tunnel. What you see there, it's a little different from what you see there now. It's actually flat and even. But there was some digesters there. We had to have a site, a good site to sink down the shaft so we could start it.
And I think this is actually where the plant actually started. If we look, think back on the maps we had back to 1938, where you had those anaerobic digesters. And so what we're doing is we're actually cleaning that old technology out as we're putting in almost $4 billion worth of all types of new technologies. And so this is really a massive investment, but it's also a massive construction project.
It is a massive construction project. As I said, we're only in the early stages of the project, the actual physical construction. Over the last 6 years, we've been doing planning and design. We're actually into the first. We're actually into the first tunnel contract now. It's a design-build contract, so we're actually doing the design and getting ready to do the construction.
Well, I know there's over 1,000 employees as far as DC Water is concerned. Of course, that's both sides, the water and the sanitation part of that. But do you have any idea about the number of workers involved in the construction in the various projects on the site?
There will be several hundred workers. The tunneling itself is more equipment intensive than manual labor, but there will be a lot of surface construction. There'll be a lot of jobs from that. Plus, we're trying to do more low-impact development, green infrastructure, and that would generate a lot of environmental jobs.
And this is what we're talking about here. This is really the wave of the future. If you look at all the square footage on the buildings around Washington, D.C., actually any city around the globe, whether you're in Rio de Janeiro, you're in Beijing, Shanghai, London, Paris, wherever it may be, we have these huge surface areas on the roofs, and we need to be thinking about how we can turn these into green roofs. And Donal, I'm going to let you talk about that, but also in some of the roofing systems I know going on in countries where you're actually combining the green roof with solar and wind generation on both of those, so you're getting almost triple duty as far as that roof is concerned.
Yes, for any of the green infrastructure, you're getting double benefit. You're controlling CSOs, which also have a whole lot of additional benefits, such as reducing heat islands, increasing shade, increasing habitat, increasing property values. The more green infrastructure you can do, the better, because you're basically turning impervious paved area back into the green area and capturing stormwater before it gets into the system.
And it's actually even filtering out a lot of the pollutants and the pathogens that would be going out into the water. So there's just so many benefits that you have from that. But looking at this roof also, what you're doing is taking something that's really just a dead cost. It's a dead space. and you're really turning it into its own economic zone, because I know, like in Manhattan and downtown New York, actually they're converting many of these flat roofs to gardens and selling the vegetables right into the local community. So that goes to food security. But I tell you, this is just a beautiful photograph here that we have in this slide. Tell us a little bit about what we're looking at.
Again, that's other types of green infrastructure. The green roofs is one type. What we're looking at here is a curb bump out, where you have inlet. There's stormwater water off the street is actually going into that green area. And the one on the left is just your plain old-fashioned trees. You know, they retain water as it falls. Because what you want to do is delay it in many cases. If you can attenuate it or delay it and allow it some time before it gets into the system, it comes into the system after the rainfall, so it helps tremendously.
Well, if we look at, we've had the leaders from the Anacostia River on here, and we saw some of the destruction just by the actual volume of the water that's going into these tributaries, and it's an amazing amount of land that's actually being destroyed and undergirding the infrastructure within many of these areas. So having these rain gardens and also having the number of trees that you have in cities, and of course this is something that people are really looking at, is how do we actually plant more of these. But this is really what we're looking at here. This buffer zone is very important. It looks very lovely, but actually this is serving a very profound environmental use as we're looking at the cleaning up the river.
Yes, and what we want to do is have more green area, basically, especially in the combined sewer area. I mean, there's benefits in the separated area too, because it retains stormwater. But the more green area you can have, the better. Unfortunately, with the Anacostia, we were under much tighter consent decree deadlines, and we weren't able to. We've done some low-impact development, but we needed the certainty to meet the consent decree. There's nothing more certain than an engineered solution like a storage tunnel. Low-impact development needs a little bit more testing. I mean, it needs monitoring, you know, before you do it and then after you do it. So we need to do some demonstration projects to get a better idea of what it can do for us.
So looking at this, we'll just leave this image behind us because you only have about 30 seconds left, Donal. What would you like to leave with our viewers both here and abroad as far as this low impact and non-mechanical ways as far as filtering water, slowing down the velocity, and improving the quality of water as it goes into the tributaries?
Well, I'd say anytime you can turn paved area into impervious area, you're doing well. This beautiful river here is the way we want it to be. It's not as clean as it looks. We'd like to get it a lot cleaner.
Well, if we can do it and lower the impact on the taxpayer and have a benefit, thank you for being with us as we create the Emerald Planet.
Around the world, 1 out of every 3 women will be beaten or otherwise abused in their lifetime, often by a family member or loved one. A future free from violence. It's all she's ever wished for.
Did you know you have the power to stop children from joining gangs? You can help a father find a job and home for his family. You can assist a woman who can't afford the medicine she needs to live and the home she can't live without. You can choose to make a difference in our community. Support Volunteers of America, and you can help improve the lives of nearly 2 million Americans each year with programs and services that help individuals and families overcome their challenges to become as independent as possible. Support the programs that are working in our community. Contact Volunteers of America today. Call 1-800-899-0089.
For some folks, saving for the future is easy, but for you, it might take a little more effort. Saving for your future is your responsibility, and there's a lot to save for.
I never thought of that.
Like your child's education, perhaps uncovered medical expenses, or just to be sure you can live the way you want when you retire. The time is now to save for tomorrow. Save now or work forever. The choice is yours. Choose to save.
We're back to the Inside Scoop Emerald Planet. Here again, your host, Dr. Sam.
Thank you for being with us as we come to you from the United States, looking around the globe for those 1,000 best practices, the technologies, the services, the products, and the people that are making a difference as we move through the 21st century. One of those things that are truly impacting on the welfare, the health, even the education, the food security, is the whole notion of how do we deal with the massive amount of wastewater that's being generated from now what is an urbanized population. As many of you know from tuning in to past programs on the Emerald Planet, 54% of the world's population of the 7 billion souls are now living in urban areas. That generates a tremendous amount of wastewater. And how are we going to be able to take care of that, to transport it, to treat it, and then make sure that we're not only just taking care of it, treating it to be neutral, but how are we going to actually improve the quality of the water? I had a chance to go out and visit the largest such tertiary facility in the world in Washington, D.C., called Blue Plains. I think that's a very appropriate title. And Dr. Sudhir Murthy is sitting right beside me. He was my guide in that. He is a PE professional engineer, as well as having his doctorate in engineering. So we're really blessed to have you, and you're the head manager of research in the laboratory there. So what is it about these nutrients that we need to be taking out of the water, and just what are the nutrients?
So really nutrients are, there are two nutrients, there are many nutrients, but the two main nutrients that we need to take out of the water is nitrogen and phosphorus. And it's nitrogen is what we eat. We eat it in form of protein. Protein contains nitrogen, and phosphorus is also it's present in food, and all of this gets washed down into the wastewater, and then it gets into the wastewater plant, and we need to remove that nitrogen and phosphorus before it gets into the river or in the Chesapeake Bay or any of these estuarine systems, and the reason we have to remove it is because they will cause harmful algal growth. And if you cause this harmful algal growth, it really sucks up the oxygen and really destroys the rivers.
Yeah, we've had in one of the earlier segments, we talked about just the huge nature of the facility, the cost, over $3 billion, and what we're looking at, another $4 billion being put into this facility. And what we're trying to do is we're not only, as I understand it, to sit here, your job is not just to keep all this neutral because of the changes that happen, the climate changes going on, but actually you're trying to improve the water that is actually coming in, so whatever is discharged into the river actually is a higher quality as far as drinking quality level than what was actually may have been in the drinking water in the very beginning.
That's exactly right. The level of treatment that is undergone in Blue Plains really cleans up the water to much cleaner levels in many ways, especially with regards to nitrogen and phosphorus.
Well, and also the carbon.
And the carbon.
Yeah,
and the carbon.
I was going to say, the carbon is a huge amount of waste that's being extracted and then,
that's exactly
and then neutralized and then put out for agricultural purposes.
That's exactly right. And so what we're trying to do now is, okay, we have to remove this nitrogen, we have to remove this phosphorus. How do we go about doing this in a very sustainable manner? How do we do it? We are environmental engineers, many of us at these wastewater treatment plants. How do we do it in a sustainable manner where we use less energy and do it in a way that has much lower carbon footprint on Earth?
Well, and this is the one thing that we need to realize as we have this chart in behind us, and this is something, Sudhir, coming out of India yourself, is that you're looking at China, India, Brazil, Russia, South Africa, many of these nations, the populations expanded very rapidly. but the income levels are expanding at a very rapid rate. So the amount of food intake that they have to sustain is a much more sophisticated level, much more complex proteins, carbohydrates, and the solids are being discharged into that. So it's not just this is our grandfather's old wastewater treatment facility, is that we not only need to, again, to emphasize this maintaining, we need to actually get ahead of what's going on here, but it needs to be done globally. So if we're talking about $4 billion put into really in one municipal system, just think about the trillions that need to be invested around the globe to be able to handle this. And we're really looking at, this is the challenge, looking at this nitrogen, the phosphorus, and the carbon is the same challenge we have everywhere in the entire globe.
That's exactly right. So, we may call it challenge, but we can also call it an opportunity, right? And the reason is
I like your attitude. This is the opportunity, okay?
And the reason it's an opportunity is, I think today we have so many new and interesting ways of doing exactly what we used to do in the past, but we can do it at lower costs and with less energy and with less chemicals. And if we can do all of that, everyone benefits. And so I think we are going towards a new era of wastewater treatment and removal of nutrients, and I think everyone's going to benefit.
And so again, this is making the water sustainable, the land sustainable, the air sustainable, and we're looking at this vast area we have here. What is it exactly that our viewers are looking at, and what is the impact of this, and is there any differences as far as the variation in colors in this satellite photograph?
So what you see there is the Chesapeake Bay, and the top part of the picture is the Susquehanna River that ends up becoming the Chesapeake Bay, and to the left you see the Potomac River, and those two are the main rivers that enter the bay. There are several other rivers downstream, and these rivers are really slow moving once they're tidal, and the bay is also a very slow moving water system. So an average water molecule that leaves Washington D.C. may take as much as 3 months by the time it leaves the bay, and so if that water molecule contains nutrients, we need to remove those nutrients, because if those nutrients are going to be sucked up in those 3 months. And so what we are trying to do is develop systems to prevent that nutrient from getting into the water in the first place.
And I think this is something, I've talked about this in earlier segments in this particular program about Blue Plains and the positive impact that this huge facility, 153 acres, has. But we have to realize that this water is not just being discharged in our own river, the Potomac, in our own Chesapeake Bay, but this is going out into the Atlantic Ocean. And I think this is something conceptually that's just hard for most humans to imagine, is that I'm discharging water down my own, out of the kitchen sink or out of the bathroom, what have you, and that water may end up all the way across the Atlantic in Spain and Portugal and going to Morocco. We have no idea where this is going. And so we really need to raise our level of consciousness of what we're discharging, so that, again, go back to this recycling, how are we not putting things into the waste system so it doesn't have to go into the Blue Plains treatment facility and be extracted. Don't put it there to start with.
That's exactly right. For example, prescription drugs. There's sometimes a practice of dumping prescription drugs down the toilet. You should that's a big no-no, because that ends up into a wastewater plant, and if not properly treated, could end up in the rivers. So we need to take care of what we put down a sink, what we put down our toilet, because that has an impact on really what we value, the waters.
Now, looking at this chart here, explain to our viewers what is actually going on here. And we see all these different colorations. We have the red, the oranges, the greens. What is the impact, and what is actually happening to the water as we're looking at it?
So this is a chart from the Chesapeake Bay program, and what this chart shows is the parts of the bay that have been severely impacted, and really the program has given grades for the different parts of the bay, and but in general, much of the bay is in average or poor condition.
So really, we're all getting very low grades. So if we're in school right now, we would be in the C, D, and F range, which is actually not very good for any of us. So what do we need to be doing? Let's just stay right with this this chart we have here. What do we need to be doing right now, Sudhir, to actually get this from the orange and the reds up into the green area?
In an earlier chart that I showed, the pie charts, much of the pollution right now is coming from agriculture and stormwater, and so the wastewater treatment plants have done their job. They have reduced the nutrients. What needs to be done next is really a bigger challenge of reducing non-point source pollutions, treating agriculture runoff, or preventing it from getting into the rivers in the first place, and how we actually manage stormwater.
Now, looking at this, these 4 photographs here, this is something about the removal, and this is what you, in my tour I was taking with you, what was going on. Looking at this triangle, what is the interplay here amongst all of this?
Yeah. So, really, what this chart shows is wastewater treatment. It's got chemistry. The treatment involves a lot of chemistry, but it actually, we use bacteria. We use these good bacteria. They're actually good bacteria that actually help us with this removal of nitrogen and phosphorus. And there's been some really new innovations happening. We've been developing these new, or actually encouraging new bacteria that can actually do this work in a more cost-effective way.
Well, and the whole thing, too, Sudhir, is not to have all these huge, expensive mechanical systems, but allow, you know, something that's the anaerobic bacteria, our friends, and let them go to work.
Exactly, exactly.
Now, looking at this, we have 2 charts here. Let's go over these. What are we looking at? This is
so this chart really shows the removal of phosphorus from the Potomac River. So if you look at that peak out there, that was the amount of phosphorus being discharged from wastewater treatment plants to the Potomac River in the 70s and the early 80s. And then we started removing phosphorus. And this phosphorus is really what was contributing to harmful algal growth in the Potomac River. And we in just 5 or 6 years, we almost completely eliminated it.
Well, we're going to leave this slide up here. We only have about 15 seconds left, Sudhir. What would you like to share with our domestic and international guests about what they need to think about as far as their impact on clean water?
Well,
got to be quick.
We have to remove carbon, nitrogen, and phosphorus in many locations all over the world. We can do it in a very sustainable manner, and we can help the water and sanitation of the world.
As we do that, we're creating the Emerald Planet.